Hello, good day everyone. So in this video presentation, we're going to talk about what is weather and climate. In this next slide, I have here two images. The first one on my left, I have here a green healthy tree with a partly cloudy sky and a green field. While on the other hand, I have here a withered tree with a shiny sky and a drought land or earth. Now, based on these images, if I ask you, is this weather or climate? Now, for you to give me an answer, you're just going to base on your current observation on these two images. No, you might get confused before you answer this because maybe you're not familiar with what is weather or climate. So in this video presentation, we're going to make emphasis and clarify what is weather and what is climate. Now, going back to my question, what do you think is this? You just base your answer on your current observation in this data or images. So, this is an example of weather. Now, what is weather? Weather, this is the state of the atmosphere at any given place and time. So, when we talk about weather, it is your current observation no, at your environment. You're just going to look at the condition of the sky, how is the temperature of the surroundings, how about uh, the speed of the wind surrounding you. Okay, so weather talks about your current observation at a given place and time. So it is an exact observation. Alright, so for example, right now the temperature in Tagaytay City is 19 degrees Celsius with a partly cloudy skies. So if I ask you, what is your weather in your place right now? Maybe you will look at your window or any opening at your room, and then you will just look at what is the condition of the sky, what is the temperature, what is the room temperature inside your your place, no? Or you're just looking at how are the trees and plants around you? Are they moving? So if they are moving, what I mean if they are like shaking, no? Parang ibig sabihin nun mabilis yung wind, okay? Or if not, kung they are not moving, you can tell that there's no moving wind at all. Alright? Now, aside from that, you will look also at the condition of your floor or land or soil around you. Are they wet? Are they dry? No? So those are your observation for you to answer my question. What is your weather right now in your place? No? Now, weather describing the degree to which it is hot or cold, wet or dry, calm or stormy, clear or cloudy. So these are just some of the category that you will look onto for you to determine what is your weather in your place at any or at a specific given time. So most weather phenomena occur in the lowest level of the planet's atmosphere, and that is our troposphere. So what are the common types of weather elements? These 6 types of weather elements are essential in identifying what is the weather, what is your current weather at any specific time and place. So let us talk at the first one. You know this already, the temperature. It just pertains to how hot or cold in your place. So let's say it's getting out there. It's getting hot out there. When you talk about the heat of the air outside on a summer day, that will be your statement. So The temperature is measured with the thermometer in Fahrenheit, Celsius, or Kelvin. So those are the three units used for temperature. But here in the Philippines, what is common is the use of degrees Celsius as a unit for temperature. So the temperature tells you how fast the air molecules and atoms are moving. So fast-moving molecules and atoms mean the temperature is high, while slow-moving molecules in the air create a low temperature. Alright, fast-moving molecules of air are rising up in the sky, at least at the level of the troposphere, and the slow-moving molecules that determine that this air is cold stay underneath that high temperature air. Now, for you to have a visualization of what I'm telling, you can just imagine the simple experiment on the placement of two different glasses with different temperature of water. Let's say when we have a glass A with hot water and colored it with red dye, mix it and you mix that with a blue colored dye cold water, you will notice that there will be a one-time convection there. No, the hot water, which is color red, will go up, and the other cold blue water will go down. So that scenario can be observed also in our troposphere. All right. So if there are changes in the temperature of the air, you might see also another convection process wherein when the hot air up in the sky becomes colder, when it becomes colder, no, it will go down. And when the cold temperature of air underneath of that becomes hotter, it will go up. All right. Now, remember that any that material such as the air or even the water, when they are given a higher temperature, their molecules will really move fast. Now, if the temperature is cold, the movement of the molecules, both in air and water, will slow down. That event is also occurring or happening in other materials present in Earth. Alright, so another weather element is the humidity. It tells you whether is it dry, is the air dry, or is there a moisture or dryness of the air. So that is your humidity. This is the amount of water vapor present in the air. It is measured with this measuring weather measuring tool. This is a hygrometer. Next, we have here precipitation. It describes how water falls to the ground. So it can be of different, the water can be in different form, like rain, snow, sleet, ice, hail, or drizzle. So the water form depends on the temperature and the location where the water will fall. So kung ito ay nasa polar region, of course, we will expect an icy rainfall. So in the form of ice, hail, or drizzle. So we have here a rain gauge or this is a precipitation gauge. Now, this rain gauge, we can See, here's measuring unit. Okay, so here I have your milliliters on the left side and inches on the right side. You can make an improvise of this rain gauge if you can still remember way back your high school or elementary period. No, your teacher told you to make a rain gauge and measure the amount of rainfall at a specific given time. Let's say uh, when it is rainy season, mga June, July, and then when you place a cup of water and label it with milliliters, okay, start with the zero at the bottom of the glass or pudding cup. Then when you place that at your roof, then you come back after 1 hour, then you can now measure the amount of rainfall in that 1 hour of time. No? So always remember now for you to measure the amount of rainfall, you should give at least 1 hour for you to measure the amount of rain in the amount of rainfall present at your place. The fourth element that we have is the wind or the amount of wind. This pertains to the air movement. So the movement of air is created by how the sun hits the earth. Okay, and then convection tells you how air moves in the predictable patterns. Therefore, meteorologists have some idea of how a storm will move or the type of weather you will have in a week. Now, as what is mentioned here, sun dictates the sunlight or how the sun hits the earth dictates the movement of the air. The movement of the air or the wind movement happens when uh, the hot or the hot temperatured air and the cold temperatured air meet together. Now, when they meet, there will be changes in their position, and you can notice that in the convection process wherein magiging mabilis yung pagpapalitan ng kanilang places. Yung hot air na nagiging nagko-cool down sila sa biglang bababa, then paikot lang yun. So, magiging cycle. Next weather element is the cloudiness or the amount of clouds in your place. So clouds are collections of water droplets in the air due to the cycle of water. So there are billions of water droplets that are necessary to make a cloud. So the four main types of cloud are cumulus, stratus, cirrus, and cumulonimbus clouds. So these are the four main types. Now, when you teach na in high school or kung yung iba sa inyo malagay sa elementary, you will also teach this four main types of clouds. But if you're going to look on the internet, there are a lot of types of clouds, no? Pwedeng one of the type here will resemble another type. So, pwedeng nagkakaanohan sila. Pwedeng nagiging combined yung kanilang classification. By the way, the temperature of the water with the densest property is at 4 degrees Celsius. Now, that is the maximum weather temperature of water to meet its highest density. Alright. And last of the types of weather elements is atmospheric pressure. So atmospheric pressure, the weight of the air pushing down on the Earth's surface is the atmospheric pressure. So since it's measured using a barometer, it is called a barometric pressure also. Now, those 6 weather elements are you're going to observe each one of them for you to finalize your at observation of your weather at a specific given time and place. So you will not just depend your answer on the temperature of your place. If I ask you, what is your weather at a specific time and place? So what are the types of weather? So here are the common types of weather. So ito yung weather chart natin na tinatawag. You can always see this in elementary school, especially sa grade 3, no? Grade 3 classroom. Ito ay start na yung iba merong as early as kindergarten pala meron ng weather chart na kung saan itinuturo na nga what are the types of weather. So what are the basics? So we have sunny day, no, cloudy day, meron tayong windy day, okay? At yung iba dito, meron na silang partly cloudy, cloudy skies, snowy, okay? Meron na din silang stormy, and etc. Now, here are the common types of severe weather conditions, such as thunderstorms, tornadoes, hurricanes, typhoons, cyclones, winter storm, blizzards, and droughts. So this depends, for example, droughts is the absence of rainfall. It's not just the water, no? Kasi in desert, there is drought, but we have two kinds of desert. Merong yung hot desert at merong cold desert. Yung talagang malalamig na desert, no? So, walang presence kasi doon ng rainfall in a span of a year. Okay? Or kung meron man, very little. So, that's why it becomes a desert. So, meron doon severe droughtness. Now, hurricanes, typhoons, and cyclones naman, yung mga names na yan ay nababase kung saang lugar na form yung mga weather conditions na to, yung hurricanes, typhoons, and cyclones. So, depending kung saang ocean sila. For example, pag ang isang bagyo ay na-create sa Pacific Ocean, so we call that as a typhoon. So wala kang makikitang typhoon sa Atlantic Ocean kasi pag doon naman na-create ng bagyo, we call that as hurricane. At kapag na-create naman ng bagyo sa Indian Ocean, we call that as cyclone. Cyclone hanggang doon din sa part ng pa-Australia. They called it as cyclone. Alright. Next, we have this. And what is climate? We talk about what is climate naman. Climate is the average condition. Take note of the word average. This is the average condition of the atmosphere, such as the other weather elements like temperature or precipitation over a long period of time. So, malaki ang pinagkaiba ng weather at climate. Kapag weather po, ito ay yung current observation natin at a specific given time and place. So, in a day, there could be different weather na mangyari sa atin, no? Now, sa climate naman, we have here factors such as average condition and a very long period of time. For example, the average annual temperature in the Philippines is 26.6 degrees Celsius. This is according to the internet. So the average annual precipitation is from 965 to 4,064 millimeters. Climate is the average of weather conditions in a place. So this is your climate. Now, di ba nga merong mga debate whether is climate change really happening or not? Kasi yung may nakita ko ibang mga vlog, no? Sinasabi, climate change is not really happening kasi doon daw sa place nila ay talagang malamig. Hindi naman daw sila yung hindi naman biglang nag-init yung place nila, no? So walang severe weather condition. But in recent researches, nakita na ang climate change ang mas prone sa pag-experience ng climate change ay tayong mga nasa developing countries. Tayo yung mga naka-place dyan sa mga critical areas katulad nitong equator na kung saan tayo ay laging binibisita ng mga extreme weather conditions like typhoon. So doon na, dahil daw sa climate change, nakakreate na yung mga uh, yung severe weather condition na nga, mas pinalakas palalo. Like yung the strongest typhoon ever in our record sa history natin sa buong mundo is yung Super Typhoon Haiyan, or sa atin yung bagyong Yolanda, no, in local name. Okay? But in the average kasi, sinasabi ng mga scientists, no, at kahit si Mang Tani, sinabi rin to, sabi niya, na on the average daw, for us to tell that climate change is really happening, no, dapat i-compare daw natin yung ating climate today or this year 30 sa climate 30 years back, no? So kapag yung climate natin ay sobrang laki ng pinagkaiba 30 years ago sa climate noon, we can say that climate change is really happening, no? But there are different, napakarami na po ng mga documentary na nagpapatunay na climate change ang climate change ay nangyayari. But for us to help or to mitigate the problem caused by climate change, kasi it causes global warming, no? And dahil doon, nagkikreate tayo ng severe weather conditions, dapat meron ditong political will. Kasi dapat ang nagre-regulate talaga ng, halimbawa, pag-create ng large carbon footprint that causes climate change din is yung government, no? So, kaya nga may mga na-create na mga treaty, no? Para ma-lessen yung ating mga carbon footprint. At ang goal nun is hindi or mapabagal kung hindi man matigilan yung climate change, no? So, yung mga dating news na sabing may malaking butas na sa ozone layer, but because of this pandemic daw, dahil nabawasan yung pag-consume ng mga fossil fuels kasi hindi naman masyadong lumalabas yung mga tao, no? Or nag-i-stay nga lang tayo sa bahay, nababawasan yung pag-consume natin ng mga energy, yung mga non-renewable energy gaya ng fossil fuel, yung mga diesel natin, gasoline, no? So, dahil doon medyo bumaba naman daw yung ating carbon footprint emission, and then na medyo napapagaling na daw natin si ozone layer sa ngayon, nakita nila, no? So compared doon sa past 5 years ago na kung saan malaki ang butas ng ozone layer. At may nakita rin akong isa last time sa Facebook na i-compare nga yung changes sa isang ice cap, at may mas malaki pa sa Manhattan City sa New York na masisira na at kakalas na siya sa isa pang mas malaking ice cap, at yun ay nagpapatunay din na ang ating ocean temperature ay tumataas kasi natutunaw na rin yung ating mga malalaking ice cap and icebergs, no? At dahil doon tumataas yung water sea level. Okay? ang pinaka-damage daan sa water sea level niyan ay yung bansang Mali. Sila ay nabubura na sa mapa at lumulubog na po. Ano? Okay. Now, going back here, just as the weather differs from day to day, the climate differs from place to place. Okay? So, weather changes from day to day, or pwedeng in a day there are different weather, but in climate, it differs from place to place depending on the area that you are observing, or pwedeng depending on a larger scale yung region sa Earth. Okay? So, yung mga magkakaiba na yung climate sa mga countries na nasa tropic region, sa Tropic of Cancer, Tropic of Capricorn. So, yung mga areas, region of Earth na yan, ay iba na yung kanilang climate. Alright, so katulad nito, ang climate sa Tugigaraw, so this is the average, warm and dry daw. Okay. Next is Tacloban naman, called cool and wet, kasi ito ay laging dayuhin ng mga bagyo. Okay. And then sa Sahara Desert, hot and dry. Talagang hot and dry doon. Pero sa Alaska naman, no, dry siya, but it's cold. Kasi depende yan sa kanilang region kung nasan to mga places na to. So, nagbigay ako dito from Philippines and other countries. Now, a climograph. This is a graph that indicates the average temperature and precipitation for an area. So these graphs can answer the following types of questions. How much rain is there in a particular location? And when is it dry? Is it wet? Or when it's cool? Is it wet when it's cool? Or what vegetation can grow there? So these are some of the questions that might be answered using a climograph. What is a climograph? What is an example of climograph? Ito siya. So you have there, look at the title to see what's location's climate is being described by the graph. So here, this is the climograph of Mangalore in India. So at the left side, you can see the numbers on the left side show you the amount of precipitation. So make sure you check to see if the precipitation is measured in millimeters or inches. So this one is in millimeters. Okay. So at the bottom, the letters at the bottom show you the months of the year. And the numbers on the right show you the temperature. So this is in degree Celsius. Now, you can also see there a line pointing what is the millimeter per year. Okay, that line. And this is the line graph with the red line. No? Ano naman, temperature, the average temperature in a month is shown with a blue bar graph. Okay. Alright, how to read a climograph. The bar graph measures the average precipitation for each month. So the numbers that measure it are on the left side of the graph. So this tells us what is the average precipitation in each month. So this is average from January to December. The line graph shows you the average temperature for each month. So the numbers that measure it are on the right side of the graph. So ito yun. So the average temperature in January is about between, I think this is 28 degrees Celsius. So in January, and then the highest temperature is in the month of this is April and May in Mangalore, India. Okay, this is I think 29 degrees Celsius. Alright. One factor that that affects the temperature of a place is the amount of sunlight it receives. Notice how the temperature line is on the Clima graph is almost level. This location is near the equator. It receives the same amount of sunlight all year, which results in an almost straight temperature line. As you can notice, it is very similar to a straight line. It maintains its temperature between 25 to degrees Celsius for a year. So its location is near the equator now for that kind of average temperature. So this place in Mangalore, India is categorized as a tropical wet and dry location. Okay, why it becomes tropical wet? As you can notice at the in the month of June and July, they can experience as high as about 1,000 millimeters, no, during those months. And then this is an average of dry location because of its uh, uh, because of the months that they are not experiencing um, rainfall, and they are consistent at their temperature at about 25 to 30 degrees Celsius. Now, in this place in Memphis, Tennessee, the second location is furthermore the equator. The curved temperature line shows that the amount of sunlight this location receives varies with the seasons. So as you can notice, in January it has at about 4 degrees Celsius near the freezing point. So it's very cold here. And then at the time of at the month of June to September, that's the peak we're in. They can experience about 25 to 30 degrees Celsius. So this is I think their summer time. So pagdating na ng November, December, it's getting colder na in preparation of the winter season. So this is a humid subtropical location. And now, what about their amount of precipitation? So you can see that their precipitation does not exceed 150 millimeter per month, no? So ayan, ito ang January and December yung kanilang peak ng precipitation, but it's in the form of I think very cold rainfall na yan. It's not in the form of snow kasi it's not yet freezing point of 0. Now, study the two climate graphs below. Okay, so you can see here a what do you call this? The place is not indicated, but you can notice the amount of precipitation, the temperature, and the months. No, so as you can notice, this is similar to the last climate graph I shown you in Memphis, Tennessee. So you can notice that their temperature changes in every quarter of the year. So pagdating ng this December to February is their coldest season of the year. So ito ay below 0 to kasi near to -5 itong during December, no? And then yung kanilang amount of precipitation, ang kanilang maximum is mga bandang June, mga 100 millimeters lang per month. So, konting rainfall lang din, no? So, while the other one, sa climate B, yan yung kanilang average temperature. So, hindi lang in-indicate kung anong unit of measurement nila. But I think the unit for this temperature is in Fahrenheit. So about, let's say, nasa 70 degree Fahrenheit yung kanilang temperature, almost 70 or more or less 70 in every month. So that's about mga 21 to 23 degrees Celsius, no? So now in their precipitation naman, at ang kanilang peak is during January at December. At pagdating naman ng June, July, August, ayan ang nawawala na yung kanilang sobrang baba na kanilang rainfall. Almost wala ng rainfall yan during this June, July, August, September. Ayan. Okay, so this is in climate B. Okay. Now, I have here a question. Can you pick out the one that depicts a tropical climate? Alin kaya yan? Climate A or climate B? So, while you are thinking of your answer, you must consider the amount of precipitation and temperature in all of the months, no? So, if your answer in my question is climate B, no, then you are definitely correct. Climate B is an example of a tropical climate, no? Doon pa lang sa precipitation, makikita na natin, sa amount of temperature, makikita na natin sino yung location ay near the equator o yung nakakapag maintain ng almost the same temperature in all months. If you will look onto climate A kasi, ito seasonal yung kanyang temperature. So, every season nagbabago yung kanyang temperature. So, ito ay merong 4 seasons. Na pagdating ng December, January, February, ito yung mga freezing point time nila. Now, so we know already that climate B is a tropical climate. Now, remember that in a tropical climate, they always enjoy different amount of precipitation in a month. What I mean, their amount of precipitation during the whole year is changing, no? So for let's just base here in the graph. So here, their peak of the most rainfall in a month is in November to ayan hanggang March, no? And pagdating naman sa June, July, August, sobrang baba na ng kanilang amount of rainfall. They did not include the unit in the precipitation, pero siguro dahil maliliit na numbers ito, baka malaking unit of unit of measurement ang ginamit nila dito, no? Next is this. Where is the atmosphere? Atmosphere is it is everywhere. It completely surrounds the Earth, and it is held to Earth by our gravitational attraction. So what makes up our atmosphere? Okay, so 78% of our atmosphere consists of nitrogen, and only 21% of our atmosphere is oxygen. The 78% of nitrogen in our atmosphere is stored in the upper part of the atmosphere. Ito ay bumababa sa ating sa atin dito sa lupa, no, kapag umuulan. So, ang nitrogen ay nasasama tuwing umuulan. That's why if you will notice kapag umuulan, nagiging healthy yung mga plants kasi we all know, no, that nitrogen is an essential element for plants to grow. So ito ay part na rin ng kanilang parang fertilizer. And 0.9% is argon, 0.035% is carbon dioxide, and all other is 0.06% of our atmosphere. Now, water vapor. Location of this in the atmosphere is highly variable depending on the place. Let's say sa region na kung saan nasa tropic region ka, no, yung you experience a good amount of rainfall in a year. So you have their high amount of water vapor present in the atmosphere, no? But when you go to a colder places, wala tong mga water vapor because they are already dense. Water vapor depends on the amount of temperature in a place. The liquid will become gas if there is a good amount of temperature need that is given to the liquid for it to change its form. So water vapor significantly influences climate and weather. Okay, the question is how? No, how does it influence climate and weather? So the weather and climate in a place, no, is dependent on the amount of water vapor present there. Okay, so if the water vapor is plenty in a place, then you can expect a big amount of rainfall. Eh kung drought ang na-experience ng place na ngayon, it's either, let's say, hot, yung mga hot desert or mga cold desert natin, napaka liit ng kanilang amount of precipitation or rainfall. So, ibig sabihin, mababa lang din yung amount of water vapor present in their air. Next is this one, atmospheric thickness. So, it has no defined top to the atmosphere. So, we don't know. The atmosphere is very shallow and it is less than 2% of the Earth's thickness. Over 90% of the atmosphere is the lowest 16 kilometer and is where the nearly all weather occurs. We have here temperature basics. Temperature measure of average kinetic energy that is in motion of individual molecules in matter. So 3 temperature scales units that we are using. We have Kelvin, Celsius, and Fahrenheit. All scales are relative. For example, degrees Fahrenheit is equals to 9/5 degrees Celsius plus 32. If you're going to convert the Fahrenheit to if you're going to convert Celsius to Fahrenheit, you just have to follow this simple formula. If you're going to convert degrees Celsius to Kelvin, you have to use this formula. Degrees Kelvin is equals to degrees Celsius plus 273.15. This is constant. So if we're going to look at this temperature scale at 0 degrees Celsius, which is the freezing point, that is equals to 273.15 Kelvin, and that is also equals to 32 degrees Fahrenheit. And The boiling point of water, which is 100 degrees Celsius, equals to 212 degrees Fahrenheit and 373 degrees Kelvin. Here is the temperature layers across the different levels of our atmosphere. So let us look on the different region of the atmosphere. First, the lowest part is the troposphere. Okay, next to troposphere, no? After about more than 10 kilometers altitude, you can see there the stratosphere from about 10 kilometers to till around 50 kilometers above sea level. You can see there the stratosphere, and from about 50 kilometers altitude to about 85 kilometers, you can see the the region of Mesosphere. Okay, and from above 85 to 120 kilometers, you can see there the thermosphere. And in every uh, region, they are separated by the following. Between troposphere and stratosphere, it is divided by the tropopause. For stratosphere and mesosphere, they are divided by what we call the stratopause. And in the thermosphere and mesosphere, they are divided by the mesopause. Okay, the ozone maximum is between 20 to 30 kilometers above sea level. So this is our altitude. Okay, when the sun strikes, okay, when the sunlight enters our atmosphere, okay, uh, it will it will influence our temperature in the earth. So let us look at this temperature scale at the bottom. So this is arranged from we have here about 60 degrees Celsius. Ito lang yung kanyang limit muna dito sa graph. Then to minus 100 degrees Celsius. Okay. Now, due to solar winds, cosmic rays, once it enters the thermosphere, it's very hot, higher than 60 degrees Celsius. No? And then, as it travels in the thermosphere, bumababa yung kanyang temperature until, ayan, no, about minus 90 degrees Celsius. So, ito ay below freezing point na at this point na. Okay. So, itong red line na to, it tells us ano yung temperature ng air, no, sa mga lugar na to. Okay? Pero ito, due to solar winds, ay mainit sa taas ng part ng thermosphere. Okay? So, habang tayo bumababa ng thermosphere, lumalamig po. Then, once we enter the mesopause, dahan-dahan namang tumataas yung ating temperature. Okay? Pero still freezing point po ito hanggang 0 degrees Celsius. Okay, then pagpasok naman natin sa stratopause, yan, biglang mag-change na yung ating temperature. As you notice, habang pumapasok tayo sa mga mesopause, stratopause, and tropopause, biglang nagkakaroon ng changes sa temperature. So ito, after stratopause, nag-drop down yung ating temperature until around minus 60 degrees Celsius. Then pagdating doon sa limit ng tropopause, tayo ay papasok na sa troposphere at ito na po unti-unting tumataas ang ating temperature. Ngayon, if you will notice yung mga matataas na region or landscape or places sa Earth, no? Katulad ng Mount Everest, no? Yung kanilang landscape dun ay nababalot ng yellow. Kasi nga, pag high altitude, no, sa troposphere, ito ay merong mababang temperature ang meron doon. So later I will explain bakit kapag mataas yung landscape sa region ng troposphere ng isang landmark kunwari ay malamig. It's kasi meron tayong factor na tinitingnan gaya ng altitude, no? Yung height niya from sea level, no? At saka yung atmospheric pressure. Now, due to ozone absorption of sunlight, ito kaya bumaba yung temperature dito sa layer na to na stratosphere. Kasi papasok na to sa pababa na to ng troposphere. Now, kaya naman dito mataas yung temperature at the lowest land area natin dito. This is due to surface heating, no? Dito na nare-reach yung long wave ng sunlight, the latent heat, and the sensible heat. Okay? Kasama na rin dyan yung heat na nakikreate ng mga industry dyan. Okay? Aside from industry, yung mga vehicular motors natin, they create heat, no? Lalo sa kalsada. Temperature decreases with the height in the troposphere. Okay, yun nga. Sabi ko na kanina. Alright. Now, this is the density and pressure. Okay? Sabi ko nga kanina, habang tumataas ang isang landscape or isang landmark, gaya ng Mount Everest, no? Nagiging malamig yung lugar na yun kasi meron tayong mga influencing factors such as atmospheric pressure tsaka yung altitude. Na ngayon, we look at this from 0 kilometers altitude pa 500 kilometers altitude. Now, this is itong orange or red line na to, this is it tells us our air pressure at yung white ay yung air density. At sa right side ko yung air molecules. Now, tingnan nyo. Yung air molecules, habang tayo ay tumataas, okay, yung air molecules niya ay mas nagiging kaunti. O, ibig sabihin, naninipis yung hangin natin. No? That is why habang tumataas, medyo nababawasan yung oxygen content natin sa air. No? Kasi nababawasan ng air molecules dito. Okay, next. Ito namang air pressure natin, the same as air density. They are directly proportional to each other. So, kung mababa yung ating altitude, mataas din yung ating air pressure doon at air density. So, habang tayo ay tumataas ang altitude, bumababa naman yung ating air pressure and air density. So, that is why, no, sa troposphere natin, kung babalik tayo dito, tingnan nyo sa troposphere natin, pagdating ng altitude ng around 10 kilometers above sea level, ay meron na tayo doong napakamababang temperature. Okay? Sobrang baba niya, nagkakaroon na ng mga frozen materials. Okay? So, yung ating temperature across the layers of the atmosphere varies because of different reason, no? Katulad niya sa ozone layer. Sa ozone layer, kaya bumababa yung temperature pag dating dito kasi ina-absorb yan ng ozone layer natin yung heat na nakakuha natin directly from the sun. Okay? Now, what is an atmospheric pressure? Okay? This is the weight of the overlying air. Okay? So, the taller the column of the air above an object, the greater the air pressure exerted on that object. So, look at this graph. So, at the left side, we have there the altitude in miles. So, this is the place that we're going to compare, Bombay, India, and Mount Everest. And this is the altitude in kilometers naman, no? O tayo tumingin. So, ito yung sea level, high air pressure kapag mas mababang lugar, no? Okay, kasi sabi dito, taller the column of air above an object, the greater the air pressure exerted on that object. Kasi yung itong place na to sa Bombay, India ay napakamababang place. That is why mas mahaba yung column, air column natin dito. Oh, dahil mahaba yung ating air column dito, yung kanyang air pressure is mataas din. No? So, dito naman, sa Mount Everest, yung pinaka-peak niya, kung i-compare nyo dito, maiksi na lang yung kanyang air column compared, vertical air column ang pinag-usapan natin. Ha? So, dahil doon, it has a very low air pressure. Okay. This time, we're going to talk about standard atmospheric pressure. It is sometimes used as reference or standard pressure. It is approximately equal to the Earth's atmospheric pressure at sea level. So we have here the standard. I will just write here 1 atmospheric pressure. This is equals to 101,325 Pascal, or the PA. That is also equivalent to 1013.25 hectopascal. That's equals to 1013.25 millibars. Okay, so these are all other conversions of 1 ATM. Now, if we're going to talk about if we're going to use mercury in determining one atmospheric pressure, it will span at about 29.92 inches. We're going to use mercury in determining the standard atmospheric pressure. That is the height of the mercury at 29.92 inches. Here are the layers of the atmosphere. We are done with the troposphere. Let us just review this. Next is the tropopause. Okay, after the tropopause, we will now enter the stratosphere. And just a little above the stratosphere, you can see there a thin layer of ozone. After that is the stratopause. Then you will enter the mesosphere. After the mesosphere, you have there the stratopause. The mesopause. And after the mesopause, you can see there the thermosphere. Okay. Now, let us go to them one by one. Let's talk about troposphere. This is the lowest region of the atmosphere that contains 1/2 of the Earth's atmospheric density. So above 12 kilometers from the sea level, you can see there a drier air, but cold but dry air. Okay. Next, you can see the tropopause. This is the jet stream. Okay. This is where almost many jets fly. Okay, they are flying almost above the clouds. At the left side of the graph, you can see there the density and pressure. As you increase the altitude, you decrease the atmospheric density and atmospheric pressure. Okay. So density and pressure are directly proportional, but inversely proportional to the altitude. Okay. So moisture concentration increases as you have a lower altitude. Now this is the temperature, okay, at different altitude in the troposphere. Okay. So you have there an average of 20 degrees Celsius in the lowest part of the troposphere. Okay. The red line tells us the temperature, and the direction, the arrow with right-headed uh, the right-headed arrow tells us the direction of the wind. Okay, now this is an example of the tropopause. You can see there uh, almost all of the cloud formation. All right, the depth of the tropopause. This is just after, or this is the border between the troposphere and the stratosphere. The height is variable. The height of the tropopause varies because of the thermal expansion and contraction. Okay, all right. So, and the average position of the tropopause, it lies at around 9 kilometers altitude. And during the average summer position, tropopause expands up to about 15 kilometers altitude. So how do we determine where the tropopause is located? Okay, so tropopause height is proportional to the mean of the tropospheric temperature. Okay, so again, you can see this. The violet line tells us the mean uh, of tropospheric pressure. The tropospheric pressure for this warm air is up to 10 kilometers altitude, and where in the colder tropospheric temperature, you can see it up to here 3 kilometers altitude, and the tropopause lies above them, and you can see the average, or the mean. The tropopause lies between the mean of these two different atmospheric temperature. Okay. So again, tropopause. So the high-tech jets such as F-35 of the US can fly up to more than 20 kilometers above sea level. Okay, but the passenger, yung mga ating transport military vehicles such as the C-130 can fly up to more than 10 kilometers above sea level. Now, let us go to the stratosphere. The temperature increases with an increase in altitude. What do you call this? So you can see the aurora borealis, and um, you can see aurora borealis in the northern hemisphere and aurora australis in the southern hemisphere of the earth. So aurora borealis can be seen in this region or in this layer of the atmosphere. Why is there a temperature inversion in the stratosphere? Yung sudden change in temperature after the tropopause. The temperature inversion, temperature warms with height instead of cooling with height. So let us go back here. Again, sabi niyan, temperature warms with height instead of cooling height. Ito yung kanina. Okay, ito yung sa troposphere. Ayun, as we go up, temperature increases as it enters the stratopause. Okay, ozone layer is the region where the gas that absorbs ultraviolet or solar energy. It increases the temperature of the air that surrounds the ozone. So since you can see the ozone at the almost top layer of the stratosphere, where the ozone absorbs the harmful UV solar energy, that's why it becomes warmer than the other than the lower part of the stratosphere. Now we go to the mesosphere, where you can see the blue light. Temperature decreases with an increase in altitude. So ito, from stratosphere na medyo tumaas yung temperature mo as you go high to the altitude. Ito, after makalagpas mo doon, babalik na naman tayo sa mas decreasing temperature. No? So this is where meteor burns up while entering the Earth's atmosphere. At yung ibang maswerte, nakakapasok at nagiging meteorite. No? Pag nakalagpas, nakapag-survive sila sa mesosphere. So now, let's talk about thermosphere. This is first exposed to the sun's radiation, and so this is first heated by the sun. So ito yung pinakamainit. That's why it's called thermosphere, the hottest layer in the atmosphere. Air, or the air pressure here, is very thin that a small increase in energy can cause a large increase in temperature. So this is the vertical structure of the atmosphere. Okay. So at about almost 30 kilometers, you can just have there 1 MB, a very small atmospheric pressure. And as you lower down your altitude, you can get the standard atmospheric pressure, no, at 180 m, or more than 1013.25 millibars. This is an image of a space shuttle that endeavor straddles mesosphere and stratosphere. So you can see there almost the blue light at the mesosphere. So the planetary winds, this is well-defined pressure patterns that exist across the Earth that induce the global wind patterns on the planet. So this is the example of the planetary wind. This is what we call the idealized single cell convection model for a planet. No? This is just the ideal planetary wind. So the features of this circulation pattern as follows: the horse latitude, trade winds, cold drums, prevailing westerlies, polar easterlies, and polar front. Now, when you look at this model, you can see this features of the circulation pattern at different regions of the Earth. Okay, so the polar easterlies, consider the polar region and the polar high. Okay, so the wind rotation here just surround the polar region. Then I consider the convection above the polar region, and another convection at the between the subpolar low area. Okay, this is at the above the subtropical high. Next, you can see the Hartley cell, another convection region below between subtropical high and the equatorial low. Okay, and the westerlies, these are the wind coming from the western part of the Earth, or I mean the western hemisphere. And then between the Hartley cell, since this is the region of the Earth where you can see the convection near the equatorial region, you can see the formation of clouds. At the middle of that, you can see the doldrums. Now, the trade winds, trading the winds from easterlies coming from both northern hemisphere towards the equatorial low, and the easterlies from the southern hemisphere. Okay. Now, this is the three-cell model. You can see here, let's start at the top, the polar cell with the northeasterly winds at surface above the subpolar low and below the polar high. So the next to it is the convection area of the southwesterly winds at surface, below the subpolar low, and above the subtropical high, or this is called as the fertile cell. Now, these are the convection region of the polar cell. This is for the fertile cell. Now, you can see here the subtropical high, air subsides, and this is considered as a dry climate at the subtropical high. Next is the Hartley cell. Hartley cell, this is the tropical convection cell as it is located at the equatorial plate. And this is what we call the uh, ITCZ. ITCZ stands for Intertropical Convergence Zone. At this point, many typhoon and weather disturbances are created at this convection region, wherein the winds from northeasterlies and the winds from southeasterly, or the trade winds that we call, meet at the at this level, no, at this region, the ITCZ. And at this area, you can see there a low pressure area. Kaya ngayon pag naririnig niyo sa balita, any the typhoon or the storm starts at a low pressure area. So dito nakikita yan. Next, we have the ITCZ. This is a surface low pressure with clouds and rain. Yung katulad din yung nauna kong pinakitang model, nakikita doon yung formation of clouds. Okay? So, there you, after the ITCZ, no? Or this is the region, kung i-compare natin dun sa naunang model, Hadley cell. Ito, Hadley cell, then yung region dito, yung convection region sa part na ito. Okay, so after nun, kaya siya tinawag na 3 cell lang, meron lang tayo polar cell, fertile cell, and the Hadley cell. Okay, so same lang din. So if kung hatin natin itong Earth natin at the median plate, you can see the low pressure area at the equatorial plate, and then above that you can see the northeasterly trade winds and a high pressure area. Next is the westerlies, the winds coming from the west, then low pressure area, then above that the easterlies and the polar high. Okay, then the same lang din yung dun sa baba. So they are symmetrical. This is the observed distribution of pressure and wind. So in this first image, an imaginary uniform Earth with idealized zonal continuous pressure belt. So this is the idealized model of the distribution of pressure and winds across every region in the Earth. Okay. Okay. Now, at the letter B, at the second image, you can see there the actual planetary wind belts on Earth, taking into account continents and ocean currents. That is why hindi lahat ng ating mga typhoon or storms ay nakakreate lagi sa ITCZ at the equatorial plate, because hindi man exactly at the same location pero pwedeng yung maging makakapag-create tayo ng storm or typhoon little above the equatorial lower where you can see the ITCZ, but still it will be created within the said region. Okay, so if you will notice, tingnan yung subtropical high, it's not really like a linear region in Earth. So ito ay it can be it can varies in every places. It can be wider or pwedeng mas narrower. Okay, but still you have there the westerlies. This is the easterlies. This is the northeasterly trade winds. And sa baba naman, equatorial low natin, makikita natin yung southwesterly trade winds, then after yung westerlies ulit. Okay. Now, the idealized pressure belts at the equatorial low, you can see there a warm air rising creates cell of low pressure that will become later on a typhoon or a storm. So at the ITCZ or Intertropical Convergence zone, this is referred to as the convergence zone because this region is where the trade winds converge, yung in-explain ko kanina. So ascending air leads to the cloud formation, which makes this region clearly visible on the satellite imagery because of those white colors of the clouds. So the subtropical high, these zones are caused by primarily Coriolis deflection, which restricts upper level winds from moving poleward. Okay, so subsiding air and divergent winds at the surface cause warm cloud, free weather. Many large deserts areas are located along these latitudinal belts, so it can be a cold, it can be napakaliit ng rainfall or precipitation in these areas. Kaya makikita natin yung large desert areas dito. Subtropical highs tend to persist throughout the year with the center of the high migrating and are regarded as the semi-permanent pressure systems. The subpolar low naman is located around 50 degrees or to 60 degrees latitude of the Earth. This is associated with the polar front. So the belt of low pressure is formed by the interaction or convergence of the polar easterlies and our westerlies. The polar highs, they are located over the poles. So the process which produces the polar highs is different than the process which produces the subtropical highs. Surface cooling is the principal reason of the polar high. Yung mga letter H doon, ito, yung mga H niya, it pertains to polar high. Ito naman polar high, no? So yung L nito, ito yung subpolar low. L na to, subpolar low. This one, H is the subtropical high. Ito naman ang subtropical high. At this middle, you can see there another area where yung mga low pressure area natin na magiging typhoon or storm later on. Kasi nga dito na nakakreate yung napakaraming cloud formation sa ITCZ. Sa ITCZ doon nagko-converge yung easterlies and yung easterlies natin from north and southern hemisphere. Okay, so saan ba ako? Dito na tayo. So the ITCZ is a band of clouds across the tropics. Now, as you can see, there are rotational bands of clouds at the tropic part. Okay, so little above the median plate. Okay, so ayan kung notice nyo. So yun yung mga pwedeng maging bagyo. Okay. The three-celled model versus the real observation. So Hadley cells are close approximations of the real-world equatorial winds. So Ferrel and Polar cells naman do not approximate the real-world winds very well at all. Okay, so yung kung nakita nyo dito sa letter B, no? So hindi siya totally the same as what we are expecting or what is ideal. Model is unrepresentative of westerly flow adapt. Continents and topographic irregularities cause significant variations in real-world wind patterns compared to the model. So, yung mga may high places, ay may mga landmark na may high altitude, it can cause different wind patterns. No? So, yung mga matataas na altitude, pwede nyo mabasag yung mga strong wind direction na papunta sa kanila, no? At dahil kung sa likod ng mga bundok, meron doon mga big plains, no? Pwede doon naman magkaroon ng another strong wind direction or wind flow, ating tawag. Kaya may mga Great Plain katulad sa Oklahoma, doon yung malaking chance ng tornado kasi nagmi-meet yung hot and cold air, mga convergence natin. Semi-permanent pressure cells are large areas of higher or lower atmospheric pressure than the surface average. So they may be thermally induced, so rising warm air or subsiding cold air, or may be caused dynamically by converging or diverging wind patterns. So they are fluctuating seasonally. Whereas the northern hemisphere or the semi-permanent cells, such as the Aleutian, the Icelandic, and the Tibetan lows. Aside from that, meron din tayong Siberian, Hawaiian, and Bermuda Azores highs. And including the ITZZ low. Okay, this is the vertical structure and mechanisms. So, polar cells, okay, thermal part. As you can see, mababa yung average or mean tapos yung ating tropospheric pressure dito, kaya mababa din yung ating tropopause. Okay, so ito ay towards North Pole nga. So, nagko-constrict yung ating tropopause kapag malamig na region. So, this is driven by heating at 50-degree latitude and cooling at the poles. Okay, so this is another convergent region. Okay, next one. Feral cell, this is dynamical. At this point in time, no, kanyang dynamical response to Hadley and polar cells. Okay, so yung feral cell, ang kanyang wind direction towards the Hadley cell, pag ganun, clockwise. Okay, then at this point in time, dito between polar cell and feral cell, they meet or another convergence nangyayari, no? Sa subtropical low, and then you can see there a polar jet, okay, that can create another cloud. Okay, alright. The subtropical high naman, you can see there counterclockwise direction of the Hadley cell forming ITCZ at the equatorial plate. So Hadley cell thermal heating in tropics form surface low and upper level high. So air converges equatorward at surface, rises and diverges poleward aloft. So it descends in subtropics. Okay, so nakita yung iba't ibang wind flow direction, and as they converge, they can create clouds. Next slide is the average atmospheric air pressure and wind patterns in January. So I want you just to observe this one. You can just simply pause it, and you can see here the Aleutian, Icelandic low, Bermuda Azores high, and Siberian high, yung binanggit ko kaninang northern hemisphere semi-permanent cell. Ito naman yung atmospheric air pressure and wind patterns in July. So naiba siya compared to January. Ito yung January natin. Okay? Now, to sum up, when we say climate, it is what we expect. And when we say weather, it is what we get. So, again, climate is the average condition of the Earth's atmosphere in a year, whereas weather is the state of our atmosphere at a specific given time and place if you're going to observe that. So this is the end of this video presentation. Thank you for listening.